Let's discuss a very interesting phenomenon of connecting soap bubbles of different radii. Here in the setup shown in figure, there is a U tube and one side of the tube a soap bubble is made which is of radius R1, and on the other side of the tube another soap bubble is made which is of radius R2. Say if this is bubble V1 and this is bubble B2, and if we find out pressure inside B1, then we can simply write pressure inside B1 is say P1, then it will be 4T by R1 more than the outside pressure, and we know outside pressure is P atmospheric. So inside pressure will be P atmospheric plus 4T by R1, because we already studied that in case of a soap bubble inside pressure is 4T by R1 more than the outside pressure, or it is the excess pressure. Similarly, if we find out the pressure inside the bubble B2, and this will be say P2, it will be P atmospheric plus 4T by R2. In this situation, you can see R2 is more than R1, and if R2 is more, we can simply state P2 will be less. So in this situation, P1 is more than P2. That means the air which is trapped inside the bubble B1 is having more pressure compared to the bubble B2. So when we rotate and open the valve and let the two gases or air volumes come in contact, we know well that fluid always flow from high pressure to low pressure. Here we can see an interesting phenomena will take place, that as pressure in the smaller bubble is higher, the air will start flowing from a smaller bubble to the bigger bubble, and we can see the radius of bigger bubble will further increase and radius of smaller bubble will decrease. We cannot accept it psychologically, but practically it happens, which we can see here mathematically also, that the radius of a smaller bubble will further decrease and that of larger bubble will further increase, and will decrease up to a limit such that its radius will also, it will form a curvature on the surface of this outlet of this mouth at which the bubble is formed, such that its radius of curvature becomes equal to R2, so that pressure in the two sides becomes equal. Till that level it will continuously decrease. And to understand the similar phenomena, we can see an experimental application. Here you can see through a plastic tube, here we have connected two rubber balloons. One is larger size and other is smaller. Actually, we can say the bubbles are of equal size, but in the left bubble more air is there and in the right bubble less air is there, and in between there is a clip which is not allowing the air of the two bubble or balloon to mix into each other. And in this situation, we can see as in the left side balloon, more air is trapped, so its surface will be more stretched compared to the right side balloon in which less air is there. That means we can say in the left side balloon pressure will be more compared to that of right side balloon. But in this situation, just see what will happen if we just remove the clip. As soon as you remove the clip, you can see as soon as you remove, the right side bubble air will start flowing into the left side bubble, because on right side the radius of curvature is small. So we can state even in case of smaller radius of curvature, the pressure inside would be more. Whereas in psychology we were feeling that the pressure inside the left bubble was more. But that was not true, because in the left bubble the radius of curvature is large, so it was having less excess pressure. So we can say automatically the air will flow from the smaller balloon to the bigger balloon. Now you can see if we just push by the external force the larger balloon, the air will flow forcefully from left side to the right side. And if we just push it to the level that most of the air will pass on the other side, you can see automatically this balloon will start going down and the other one will start blowing up. So this is the way we can explain in this situation the air always flow or any fluid always flow from high pressure to low pressure. That's why when two balloon or bubble are connected, the flow of fluid or gases or air will always exist, or always it flows from a smaller size bubble or balloon to the larger size balloon because of pressure difference.